we were trying to solve a system of the equations using the determinant. So we create the formula for you, Cramer one. So this is the determinant of the coefficients, and you see this is the example that we gave you. If you want to solve a system of the equation 2 by 2, so D is going to be determinant of the coefficients. We find it, we talk about it 2 by 2. If this is going to be non-zero, then you are going to have a solution. Then we find the dx. Dx means the first column are the coefficient of the x. We replace it by the constant. We find the dx, and the dx would be dx, the determinant of the x over d. So that gives you x. Then we go with the dy. Okay, we go with the dy. We change the column of the y by that constant term. You find this matrix, and the y would be dy over d, and then you're done. Since the d is done, the denominator is always a non-zero number. We talk about it. If the denominator is going to be 0, then you check the top. You see, if that was the case that we explained it, if this denominator is 0, then you check the top. If one of the top is non-zero, so you get a 5 on the top and the 0 over here, of course 5 over 0 is undefined. So there is no solution and the system is inconsistent. But if the d is 0, also dx is 0, and the dy is 0, so in that case, the system would have infinitely many solutions. Okay, so be aware of these special cases. Okay, so it's going to be the same for the 3 by 3. I just give you the official version. You are going to have x, y, z, but everything else would be the same. Okay, to get these numbers, just checking where I put it. Okay, so officially, if you have a system of 3 equations, 3 variables, that this is the one that we are going to be interested in, if you like. Okay, so this is going to be the theorem for the system of 3. Okay, so solving, if you like, it's the same thing, but officially we are going to make it official, if you like. Solving systems of 3 linear equations. Okay, 3 linear equations in 3 variables. Okay, that was the one. Okay, with or in 3 variables. 3 variables, x, y, and z. Okay, this is going to be the case. So as we talk about it for the other one, so the solutions of the system, this is going to be the system. I write it down in the form of the matrix. The coefficients, I start with the a11x, first row, a12, okay, y, and I call this one a13z. Okay, and this is going to be equal to the constant, we call it c1. And then the second one, the second row, a21x plus a22y plus a23z equal to the c2. Then the third row is going to be a31x, a32y, and the a33z equal to the c3. Okay, because the coefficients would be our matrix. Okay, the solution of this system are going to be given by, and that's it, x is equal to dx over d, y is equal to dy over d, and z is equal to, okay, dz over d. If, of course, okay, if d is not equal to the 0. And we already talked about these coefficients, if you like. Okay, and you know that I just introduced the d. D is going to be the determinant of this matrix of the coefficients. Okay, this is going to be just A11, A12, A13, and this is going to be A21, A22, A23, and this is A31, 32, and the A33. And the dx and the dy dz is when we replace, okay, we replace the column by the constant column, if you like. Okay, so I'm going to, operate it like the example so that you can see it. So this means you have to find the determinant of a 4 matrices, if you like, to get the solution of your system. Okay, we give you one of them to solve. Are you ready? So we give one system. Remember, you have to use the Cramer rules to do it. Don't do the algebra. Okay, so let's do it. There is going to be one question, just direct one, and the other one is some very interesting applications. So there you are. Example. We are going to tell you so that you are not going to use otherwise. Use. Okay, that's it. Cramer's rule means no algebra. To solve the system. To solve the system. Okay, so this is going to be our system. The system is 2x plus 2x plus y minus z equal to 3. And the other one is a negative x plus 2y plus 4z equal to the negative 3. And we have the x minus 2y minus 3z equal to 4. That's the system in question. You form the determinant of a coefficient d and start moving. Are you ready? Solution, start with the d. D is the determinant. Remember, when you write the matrix, just a column, write vertical line. This means we are going to find the determinant. Coefficients. The first one is going to be 2, 2, 1, negative 1. The second one is a negative 1, 2, 4. And the third one is going to be 1, negative 2, negative 3. These are the coefficients. Expanded to get the determinant. Remember, we talked about the formula the other night. We focus on the first row. So it's going to be the first entry is going to be equal to the 2 times. 2 times what? I'm going to do all of them at once. Okay, I'll just do this one. To remind you, then we do it in the short form, really. So the determinant, you drop the first row and the first column. So we're going to have a 2, 4. Okay, 2, 4, negative 2, negative 3. This is positive, negative, positive, minus. Minus, we get the 1. Again, first row, second column. So the determinant of a negative 1, 4, negative 1, 4, 1, negative 3. Okay, that's a positive, negative, plus, plus and negative 1. Okay, it's a plus and negative 1. You drop this one, determinant, negative 1, 2, 1, negative 2. So negative 1, 2, okay, 1, negative, negative 2. This is going to be the determinant of the first one. There. Any question? Positive, negative, positive. So just find out. So D is equal to 2 times cross multiply. You see 2 times negative 3 would be negative 6 minus negative 2 times 4 would be negative 8. You make this one into positive 8 minus, do the same thing, negative 1 times negative 3 would be positive 3 minus 4 times 1 is 1. And we have a negative over here again, minus negative 1 times negative 2 would be positive 2 minus 2 times 1 is 2. That's it. So this is going to be 2. 2 times 2 would be 4. And this is going to be 2 minus 2. Okay, and this would be cancel out. So we put them together. Okay, we put them together and we get the, okay, so what we got over here, we get seems to have a 2. I didn't miss anything. Okay, just double check 2 negative 1, because on my notes I have different numbers. 1 negative 2 negative 3, and we have a 3 negative 3. So I check it again. So
4 times 1 is 4, not 1. Where you have 3 minus 1, it's supposed to be 4.
Excellent, thank you. So thanks. Yes, very good. So what I have now is going to be 4. Now that give me a negative 1. Yes, I need a positive 1 here. Thank you. Okay, so it's going to be 4 plus, I repeat it, 4 plus 1, which is equal to the 5. Okay, so D is 5 and it's not 0, so we can continue and we hope, we sure that we get a solution. Okay, any question? That's a D. Now we have to find the dx. D sub x. You said the D sub x, you start with the determinant. You are going to replace the first column by the column of a constant. Okay, by the column of the constant. So you are going to bring the constant, it's going to be 3, negative 3, okay, and the 4. So the rest are going to be the same thing. It's going to be 1, okay, 1, negative 1, 2, 4, negative 2, negative 3. Okay, so we change the column of the x. Then we are going to find the determinant. It's going to be 3 times. Okay, I'm going to do it right away. So you eliminate this. The matrix is going to be this one, 2, 4, negative 2, negative 3. So 2 times negative 3 would be negative 6. Okay, minus 4 times, that gives me negative 8, which is going to be positive 8. That's the first one. Minus, this is just 1. So it's going minus 1 times. So you eliminate the first row, the second column. So the matrix is negative 3, 4, 4, negative 3. Negative 3 times negative 3 would be 9. Minus 4 times 4, 16. Done. Okay. And the next one is a negative 1. So minus, you eliminate the first row and the column. So negative 3 times a negative 2 would be 6. Minus 2 times 4, 8. Okay. So what is going to be d sub x? D sub x is, this is going to be 2. 2 times 3, 6. This is going to be, okay, negative 7, which is going to be positive 7. Positive 7, and this is 6 minus 8 is going to be negative 2, which make it into the positive 2. So that give you 15. Okay, so the dx is equal to the 15, and we are ready to give you the x. So what is going to be x? X is dx over d. So it's going to be 15 over 5. The result is 3. So we got x equal to 3, the first one. Any question? Now we're going to continue quickly to get the other two. Okay, so we go with the dy. So dy. dy, you have to change the second column. So the first column would be as is, 2, negative 1, 1. So the second column, we bring the constant. 3, negative 3, 4. The third column is going to be the column of a z, which is a negative 1, 4, negative 3. Okay, find the determinant equal to 2 times. You eliminate the first row and the first column. This is your matrix, negative 3, 4, 4, negative 3. Negative 3 times negative 3 would be 9. Minus 4 times 4, 16. Done. Minus the second number is 3 times the matrix. The first row, second column out, so negative 1, 4, 1, negative 3. So you multiply, that gives you 3 minus 4. Then minus times the first row and the third out, so negative 4 minus negative 3 times 1, negative 3. There is a negative here to make it into the positive. Any question? So we get the dy equal to. That gives you negative 7, so negative 14. And that would be negative 1, a positive 3. Positive 3, that gives us a negative 1, a positive 1. So that gives you negative 10. So we are ready to give you the y. So the y is a dy over d. It's a negative 10 over 5, which is a negative 2. So y is equal to negative 2. Okay, any question? So we get the dx and the dy. We need the dz. Okay, for the dz, we are going to change the third row into the constant to get the z numbers. Are you done? To get the dz. Okay, so we are going to find the dz. So that is going to be d sub z is going to be equal to, the first column is going to be just the same as the x column, negative 2, negative 1, 1. The second column is going to be the y column, is going to be 1, 2, negative 2. Okay, but the third one, you replace it by the constant number, which is going to be 3, negative 3, negative 3, and 4. You see that's going to be the 1. Then find the determinant. So this is 2 times first row, first column out, so that gives you 2 times 4, 8, minus negative 3 times and negative 2 would be 6, minus 6, minus, so this is it, and negative 1, negative 3, 1, 4, so that gives you negative 4, minus, that gives you negative 3, negative, negative would be positive, plus 3 times first row and the last column out, so that gives you negative 1, that gives you a positive 2 minus 2. Okay, so what is going to be the DC is equal to, so that gives you 2, 2 times 2, 4. Okay, so over here is a negative 4, a negative 1, positive 1, and the last part is 0. So that gives you 5. That's a 5, so z would be dz over d. It is going to be 5 over 5, which is equal to 1. So z is equal to 1. Okay, so there you are, x, y, z is equal to the numbers 3, negative 2, and 1, and then you're done. Okay, it's very easy operation that we are going to do. Okay, to get these numbers done. Okay, any question? So we have a couple of them. I think you get one special one when we review that practice one. So we get to that one and we give you. Now, there are many applications of this format that you see here. Okay, just this is just to get the system of three equation, three variables. So I'm going to give you a couple of them that we use, and we give one question and we put these applications together. You say you can use this shortcut, if you like, formula to find the area of a triangle. And this can be proved nicely. We prove it in a course linear algebra. But in this course, we just, present it for you right away. You know that there are different ways to find the area of a triangle. Okay, the area is, what's that? It's going to be 1/2 of the product of the height times the base. But there is an old-fashioned formula, we call it Heron formula, right at the beginning. So if you put them together with this idea of nicely, quickly, really, we can prove this following formula. That we do it without proof for you, but you have to know it. So what is going to be, these are a kind of application of this formula. What is the area? Area of a triangle. Okay, of course, using the determinant. And that's it. So, and the area of a triangle. Okay, the area of a triangle. Area of a triangle with, okay, with vertices. So the vertices are going to be x1 comma y1 and x2 comma y2, the second one, and x3 y3. There is a formula in algebra for it, but that formula seems to be complicated, but we can write down in short form. In this format is going to be a, the area is equal to positive negative. Okay, positive negative 1/2 of the determinant of this matrix. Okay, then the matrix is going to be x1, y1, 1, x2, y2, 1, x3, y3, 1. So if you find this determinant, the result is going to be the area of a, okay, the area of a triangle. Why we put the positive negative over here, you see? Because this determinant can be a positive number or can be a negative number. You know that the area cannot be negative. So if this determinant happens to be positive, you use 1/2 times. But if this is going to be negative, you use negative 1/2 because the negative would be positive. So basically, you must have a positive answer. If it's a negative, change it. Okay, change it to the positive. So you're not going to get two solutions. We get only, okay, we get one solution only. So that gives you a very nice formula. It's very nice. It's not difficult to prove to get that formula. You put it in the x, y, z, and this is the same formula of 1/2 of the base times the height. So when you put these together, to find the length of the base and the height, then you happen to have a short form to memorize it. Okay, so we give you 3 points and we ask you to find the area of a triangle. You just get this one right away. Okay, before getting to example, this would have various applications. So this is a triangle that you have, you see. So this is a triangle. It's going to be x1, y1, and this is the x2, y2, and this is going to be x3, y3. You see, the reason that you get the triangle is that these 3 points are not going to be on one line. If these are going to be on one line, then you are not going to have a triangle. So There is a problem in algebra that you did have it before. We talk about the points to be on the same line. We call it collinear. So previously in algebra, probably you may have this problem that 3 points was given to you and they asked to see if they are going to be on the same line. The way we do it in algebra, we find the equation of the line using the 2 points, and we check the third point in it. But we can use this idea. You see, if you give me 3 points and ask me whether those 3 points are going to be on the same line again, I suppose they are not, then I got this area. If this area happened to be 0, so this means there is no triangle, so they are on the same line. If this is not going to be 0, then they're not going to be otherwise. So you are going to be given one problems, or there are some problems using this idea. So we give you as a remark. Okay. So the remark that we are going to make, we are going to give you 2 remarks. Okay, that's the first one. So we use this fact and we say, oh, 3 points. You give me 3 points, x1, comma y1, x2, comma y2, okay, and x3, comma y3. These are going to be called, okay, are called collinear. Sometimes we write them with a hyphen in between. This means they lie on the same line. On the same line, if they cannot form a triangle. So it's going to be not triangle means this determinant must be 0. So this is going to be the case if and only if this determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1 happen to be 0. Okay, because we know that if this is going to be 0, this means they are not going to form a triangle. If they don't form a triangle, means they are going to be on the same line. Okay, so this is another nice idea that we can get it from this fact. Okay, any question? There is also another one, again, interesting. The other one is, you see, you know that if I give you 2 points and I ask you to find the equation between 2 lines, equation of a line passing through those 2 points, you know that you find the slope, y2 minus y1 over x2 minus x1, and then you write the equation of the line. So we can use this idea to find the equation of the line. You see, if this is going to be equation of the line, you already give me 2 points, so I can pick another point. So when I pick the third point, it's going to be on the same line. If they are going to be on the same line, this must be 0. So that gives me a formula for the equation of the line. You see, nice one. I have 2 of these points, so I pick something optional. I call it x and y. You see, so the second remark is going to be an equation. An equation of the line. Okay, of the line passing through or containing, passing through this point, the distinct, of course. Distinct points. The points are going to be x1, comma y1, and x2, comma y2 is given by, you see, the same determinant. But instead of x1, y1, I can pick any point I like. I call it x, y, 1. Then this is going to be x1, y1, 1. x2, y2, 1. This is going to be 0. So when I find this determinant, I let it equal to 0. That give me an equation in terms of the x and the y. You know that that equation in terms of the x and the y is going to be equation of the line. Okay, quite interesting, interesting things if you like. So that is basically what we did. Is you give me 2 points, you see, this is the x1, y1, and this is going to be the x2, y2. So what I did, I just pick another point myself. So this point is x comma y. So as you can see now, these 3 points are collinears. They are on the same line. So they cannot form a triangle. So the determinant of an area must be 0. You see, it's the same thing. So, we give you one question regarding, one of these, 2 at least. So be prepared for it. Okay, just give you one example, and then we go over the practice one. We can get the one from the practice one, in fact. Okay, let me just give you one, then we go and check the practice one. Any question? So quite interesting, there are a couple of more there are many applications of the determinant, of course. Okay, so these are the one. So you have some problems in your book, and we may ask you, for example, like okay, like this one. Example. Okay, we want to use, of course, we just focus, because sometimes I give on the test, the people use other methods and they say you didn't say that. So we are going to say that use a determinant, of course. Okay, because all of them would have some other algebraic solution. Okay, use the idea of it, use a determinant. A determinant to determine if okay, if the given points, if the given points are collinear, means they are going to be on the same line. Okay, just get checking one point to see if this is going to be the case. So the points are going to be 0, 1. Okay, 0, 1, 4, negative 2, and it's going to be negative 2, and I think it's a 5 half, 2.5, for example. Okay, so what you're going to do is quickly you just identifying that matrix. Okay, so the solution is going to be, you form the determinant, you put the points, doesn't matter how you start, it's going to be 0, 1, end up in the 1, 4, negative 2, 1, negative 2, 5 half, 1. You check this determinant quickly. Okay, you want to check to see if this is 0. So we find it. So we say that D is equal to, and the first row, this is going to be 0, so nothing. This is going to be just a 0. Okay, 0, then we get the negative 1 minus, and determinant is going to be negative 2, and this is going to be minus 5 half. Then we get a positive 1 times the determinant is going to be 4 times 5 half, 4 times 20 over 2 would be 10. Okay, would be 10, and the minus, which is going to be, okay, minus 4. Minus 4. So I get the 0, 1, 4, negative 2, and then negative 2 and 5 half. Okay, so I get the first one that may give me 0. The second one is a 1, so it's a negative 2 minus 5 half. Okay, then I get the third one, which is going to be, yes, that's it, that's 1. Probably it's not. So this would be, okay, negative 2. That gives you 4.5, which is going to be 9 half. Okay, 9 half, and this is going to be 6. It must be 0, but probably I maybe I have the wrong, but anyway, it's not. So that gives us, okay, so it's going to be 4.5 and 10.5, which is going to be, that's it, it's 22 over 2, is not. So the answer is no. I don't know, maybe that number was something else. Okay, but anyway, this is the answer is no. Let's go to the practice one. We get the 3 over there. So we just check. So we give you 2 questions from this one. One question is you just solving a system of the equation for us. The other one is these applications. You must know it yourself, that you put them together and give us the answer, okay? So it's an easy question. Usually the people have no difficulty to get it really. Okay, so this is a practice test number 3 I posted for you. You may have to check the pages to get this one. Okay, so I can show you, but I cannot share it all the time, because otherwise I will lose the one on my notebook. Okay, so let's check. So this is going to be the one that I posted for you. The first part is like your quiz. As you can see, you see the x-intercepts here. That's why I just put it in that solution. I'm going to remind you what is that part means. And these are again the application of the log, because they needed if case. And the equations are a little bit more involved. We didn't talk about the ln function, ln equation, so we are going to talk about it now. This number 5 is from the previous quiz. I just wanted to know that we give you another one. Okay, these are new. Number 6, solving a system, nonlinear system. Use substitution method. One question on partial fractions, decomposition, and the application of determine. One question is missing, I added later on. Remember that a system of inequalities and those objective function, optimization problem or linear programming. I put one later on, okay. There was one that I drop it, but then you will give it we repeat it again on that take home one, so make sure you know that. One would be given to, okay. So I'm going to go with this problem number, okay, number 10, 11, and 12. So a number 9 is missing. That would be that linear programming that I'm going to add to this. Okay, so this is it. I'm going to stop sharing this so I can get my notebook to explain it. It is straightforward problems, easy. Double check. This determinant must be nice. If you get some numbers which is unusual, probably you missed something. Go back and check it, okay? Because I will double check the one that is going to be on the test. So make sure that you don't get some fractions quite a lot. Okay, you may get some from your book, but not from here. Okay, so this is going to be our, let me just go to the new page, so if I can have it. So this is going to be practice. So this is our practice test number 3. Okay, we do this last part first. I'll go with the number 10, 11, and 12. Quickly we do take care of this. 10, 11, 12, we make it into one question. One question is 2 parts, but we break all of them over here so you know it. Okay, number 10. So in number 10, you want to find the area of a triangle. Okay, find the area of a triangle with these vertices, and that's it. We have a negative 2 comma 1. Okay, 1 6, 1 6, and the 3 and negative 1. Okay, that's it. Solution, label this information. Okay, so you have a negative 2 comma 1, 1 6, 3 negative 1. So they are going to be over x1 y1, x y1, x2 y2, x3 y3. So we go with the area problem formula. A equal to positive negative 1/2 determinant. I repeat the formula so that you have it. It's x1 y1 1, x2 y2 1, and the x3 y3 1. That's the formula. Okay, we go with the d first, then we come back and we substitute. So it's going to be d. So this is it. It's a negative 2, 1, 1. The next one is going to be 1, 6, 1. And the last one is a 3, negative 1, 1. Get this determinant. Okay, are you ready? It's a negative 2 times. Eliminate 6 minus negative 1, make it to the positive. Always minus. Next, 1 minus 3. Then it's a positive. Eliminate the first row, the last column. You see, negative 1 minus 6 times 3, 18. Any question? Just a straightforward operation. So the d is equal to 6 and 1 would be 7. 7 times 2, 14. That gives you negative 2, positive 2. And this is going to be negative 19. Okay, so it's going to be 16 minus 19, which is equal to the negative 3. So the area formula is going to be negative 1/2 times d, which is negative 1/2 times the negative 3 is going to be 3/2. Whatever unit it is, a square. So that gives you the final answer. A straightforward one, really. Don't miss it. Any question? So find the d first. If it's going to be negative, use the negative 1/2. If it's going to be positive, use the positive 1/2, because the answer must be positive all the time. So that's the number 10. Ready for number 11? Number 11. Number 11, you want to check to see if the points are going to be collinear. Okay, determine if or whether and the points. Okay, the points are going to be 0, negative 5, negative 2, negative 6, and 8, negative 1. We want to check if they are collinear. Okay, get that determinant of those metrics. So label the information, x1, y1, x2, y2, you know that. It's going to be x3, y3. Get the matrix D. Okay, substitute is going to be 0, negative 5, 1. The next one, negative 2, negative 6, 1, 8, negative 1, 1. Okay, that's a determinant that we talk about it. Find the determinant. So the first one would be 0 because this entry is 0. Minus negative 5, negative 5 times. Drop the first row and the second column. So the matrix is this one. So negative 2 times 1 would be negative 2. Minus 8. Minus 8. Okay, and then this is going to be plus. You drop the first row and the column. So this is going to be negative 2 times negative 1 would be a positive 2. Minus negative 6 times is negative 48, but there is a negative sign here, plus 48. Okay, that gives you negative 10. Okay, negative 10, and that gives you negative 50, but the positive 50 here, yes? Or the negative 50. So that gives you a negative 10. And we have 3 negatives. So it's going to be negative 50. Negative 50 plus 50. So it would be 0. Okay, so the answer is yes. Yes, the points are going to be, okay, they are collinear. Collinear points, if you like. Okay, just, if it's not going to be 0, double check it, make sure that we get it right for these numbers. Okay, so again, straightforward. Any question? So it's going to be 1, 2. And the third one is equation of the line passing through 2 points, of course, using determinant, not algebra. Okay, are you ready? So checking number 12. Okay, so let's check the number 12. Number 12, we want to find the equation of the line. Okay, find the equation of the line. Okay, the equation of the line through these points. The points are 10, 7, and okay, and negative 2, negative 7. Okay, we talk about it. For the equation of the line, you are going to label the points, solution. Okay, so this is going to be over x1, y1, and this is x2, y2. So, and the third point, we get the third point, they are going to be collinear. So the determinant in this case, D is this one. Remember, we start with the x and the y and the 1. Then these points, x1, y1, 1, x2, y2, 1, automatically is equal to the 0. Is equal to the 0 because they are on the same line. Okay, so these points are collinear. Now we substitute. So this is going to be 10, 7, 1. Okay, negative 2, negative 7, 1. And then we get the x and the y and 1. And this is automatically equal to the 0. So find your determinant. Your determinant would be in terms of the x and the y, and then we're done. Okay. So this is going to be 10 times. And the matrix is negative 7, 1, y, and 1. So it's going to be negative 7. minus 1 times y, because y minus 7 times determinant the first row and the second column out. So that gives me negative 2 times 1, which is going to be negative 2. Okay, negative 2 minus x. Okay, that's it. And then plus 1. Okay, we get the plus 1. And this is going to be negative 2y. Negative 2y, it's a negative 7, but it's going to be plus 7. 7x equal to the 0. Okay, so we can check this first one. This is it, negative 7. It's a negative 2 minus x. And the last one, which is 1, negative 2y, and positive 7. Yes, you have to simplify it. Okay, so you distribute it. It's going to be negative 70, negative 10y. And this is going to be plus 14, plus 7x. And this is simply negative 2y plus 7x equal to the 0. Combine the like terms. So what we have? We have a negative 10y, and the 2y would be negative 12y. For the x's, we get 7x and the 7x, 14x. And for the numbers, we get negative 70 and 14. Okay, so this is going to be minus. Okay, so that's going to be 56. Okay, this is going to be 56 equal to the 0. We can, we can simplify it a little bit, and then it's done. You can multiply. We can divide it by what's that? Divide it by negative 2 if you like. So that gives you 6y minus 7x, and this is going to be plus 28 equal to the 0. So that gives you the equation of the equation of the line, of course, using determinant. Okay, very nice, nice application really to get these numbers done. Okay, so we put them together as one problem. And these application types, a couple of these would be asked straightforward. Don't miss it. Okay, don't make a mess with your formula, but otherwise it's going to be easy problem. Okay. Yes, you have to simplify it. Yeah, you have to simplify. You see, you have to give us the line is in simplest form. So this is the simplest form of the line. Okay, so this is going to be the first one. Now the other one is number 8. We want to solve the system. One of these must be special. These two, I don't remember. I checked the second one because sometimes you may not get a solution. I want to see something. No, the test is not on Wednesday after the when you're coming back on Monday, not Wednesday. Okay, next week you don't have any class. So we review the test now, and then when you come back, first Monday, we give you the test. Okay, because we need the rest of the time, otherwise we won't be able to finish it. No, as is, we practice. Today we practice. Next week you don't have a class. When you come back on Monday, we give you the test. Okay, and I post the take-home one for you, give you the deadline for the take-home on Monday. I think it's the first week after December. That's going to be fine. We don't have time. We get quickly to the quiz number 4, which must be sequences and series, and then the final. Okay, so number 8, a system of the equation. Let's try to see if there is one of them must be different. So I check the second one to see if the second one would give you the one that I'm going to be interested in. So that's number 8. It's x plus y plus z. Okay, this is going to be x plus 5 plus z is equal to 2. Okay, and when I when I check the syllabus at the beginning, I forgot that the Palomar would have a week Thanksgiving, so that's why maybe I made a mistake. But I double check it, but I check it, I think that's correct. We get the Monday, but this is the situation that we have. Okay, so there you are. System Cramer rules, of course. So let's check to see if this is going to be give us that special case that we are going to be interested in. Okay, we go with the matrix of the coefficients, determinant of a matrix of a coefficients, which is going to be 1, 1, 1. That's the 1, negative 1, 2. Okay, and we get the 2, 1, negative 1. Okay, check this one to see if this is going to be a non-zero number. So it's equal to, okay, distributed from the first row. So the number is going to be 1. So the matrix or determinant is, this is the matrix, negative 1, 2, 1, negative 1. So that gives you 1 minus 2. That's the first one. Always minus. For the second, the entry is 1. So the matrix is a negative 1 minus 4. So it's going to be plus. The matrix is going to be 1. Okay. This is 1 minus 2, but there is a negative sign here, make it to the positive 2. Okay, so what is going to be the D? This is a negative 1. Okay, this is going to be a negative 5 to make it into the positive 5. Okay, positive 5. And that was a positive, and it's a 3. No, it's not. Okay, so it's a 8 and the 7, which is a non-zero number. So this system would have a solution, which is not bad. Okay, so I just double check these numbers, 263 and 1, negative 1, 2, 2, 1, negative 1. So that was a positive, minus 2, that's correct, it's a negative. So that gives me a negative 1 minus 4. And the last one is, this is 1 and the positive 2, and everything is correct. Okay, that's it. So we are going to have a solution for this one. So quickly we get the dx. Okay, the dx, we switch the first row into the constant. So it's going to be 263. Okay, 263, the rest are going to be the same. We get the 1, it's a negative 1 and 1. And this is going to be 1, 2, negative 1. Okay, distribute is going to be 2 times. Determinant is going to be 1 minus 2 minus, and this is going to be negative 6 minus 6. Okay, and the last one is a plus. What is that? It's going to be 6 plus 3. Okay, put them together. This would be a negative 2. It's negative 12, positive 12. And this is going to be 9. Okay. This is going to be, okay, that's correct. And this is going to be 9. So this is it. It's going to be 10 and 19. Okay, that's fine. So your x is going to be equal to the dx over d, which is going to be dx over d. So x is going to be 19.7. Okay, it's it. The determinant is fine, so we just keep going and get the numbers. Okay, So this is going to be the dx, and you just keep going and get the other ones. Any question on this one? So quickly find the others. Okay. So we go with the dy. dy, we keep the first row as for the coefficient of the x, 1, 1, 2. We switch the second one by the constant term. Okay, and the z is 1 to -1. Okay, that's the second one. Distribute it. That gives you a -6 minus 6 again. That's a -2 times -1 minus 4. And the last one is, okay, the first row and the last column would be out. So that gives 1 times 3 is 3. And the 2 times 6 is 12. Okay. So let's see what's going to be dy. dy, that gives you a -12. This is going to be -5 and it's going to be +10. +10, and this is going to be -9. Okay, so that gives me -11. So the y is going to be -11 over, okay, -11 over 7. So that give you y. It's probably maybe one of the problem in the book. Okay, so this is the dy, and the dz similarly can be found. Okay, so the dz is equal to, the first row is going to be the same, the first column. The second column is just the same. Okay, the third column we switch it into the constant, is a 2, 6, 3, and you get this determinant, and then you're done. So it's equal to, the first entry is 1, so the metrics are going to be -3 minus 6, always minus 3 minus 12, plus 2 times is going to be 1 plus 2. So the dz is equal to, and that's a -9. This is going to be -9 and +9. And this is going to be 3 and 2, 6. So it's equal to the 6. Okay, so your z is going to be 6, 7. So these are going to be the solution of the system, and then you're done. Okay, any question? So I hope that one of them is going to be the special case. It wasn't. I just checked the coefficient of that 8 to see if this is going to be a special. Otherwise, I'll leave it for you to do it. That was the first part of the 8. So this is another part of the 8. See, I check these coefficients. You see, if the dy happen to be equal to the 0, then you have to go and find the dx and the dy. If all of them are 0, you are going to have infinitely many solutions. If d is 0, but one of those are going to be non-zero, then you are going to have no solutions. Let's check this one. Okay, it's a 2x minus 2y. Okay, minus 2z. Okay, and it's happened to be equal to the -8. And this one over here is a -x plus 3y plus 4z equal to the +8. I just check the coefficients, the matrix D, to see if it is going to be one of those special one. Okay, let's check the D. This is going to be the D. We have 1, 2, negative 1. We have 2, negative 2, negative 2. And we have a negative 1, 3, and 4. Check this determinant to see if it's a non-zero number. Okay, it's going to be equal to, so it's the first entry is 1. So first row, first column, and that gives me negative 2 times 4, negative 8. Minus negative 2 times 3, negative 6. There is a negative here. Make it into the positive 6. Okay, minus the second entry is 2. So drop the first row, the second column, 2 times 4, 8. Minus negative 2, negative 1 would be 2. And we get the minus here. Okay, the first row and the third one would be out. So that gives you 6 minus, okay, minus 2. Okay, what's the answer? So that gives a negative 2. This is going to be 6. 6 times 2, negative 12. No, it's not. Okay, that's minus 4. So it's going to be negative 20. I put 1 in that take on 1 so that you can see it. So we can continue, get the result. I just leave it for you. To do it, I give you a break. Then we come back and we do the partial fractions and the system of non-linear equation, okay? Which is number 6 and number 7. Okay, see you in, okay, about 10 minutes. Then we'll be able to do it. Okay. So that was a system of the linear equation that we can use the determinant to do it. We talk about the system of a nonlinear equation. Okay. Nonlinear when the power of the x is not going to be 1. Okay, so we may use substitution method or addition method to do it. Okay, so I just check a couple of them for you. We give you one question. It's going to be just 2 parts, usually solving the non-linear system. Okay, so this is question number 6. Okay, solving each system. Solve the system. Okay, this system is going to be non-linear. Non-linear system. So you cannot use any determinant for this one. Okay, so a typical one is, I try the B, is the more popular, is the intersection of a circle and a line. Okay, so the line is y equal to the 3x minus 5. And the second part is x squared plus y squared equal to the 5. Okay, so you want to find the x and the y. The substitution method is the best one for this one because the y is already given to you. So we can substitute the y into the second part and then do the job. Okay, so this is going to be number 1. We call this one, and this is going to be number 2. So for the solution, we start with the number 1. Okay, from the 1, just explain it with 1 and 2. So it's going to be 3x minus 5. I'm going to take this one into the number 2. You carefully substitute. It's going to be x squared plus y, use parentheses, 3x minus 5, all squared equal to the 5. You have to square this 3x minus 5. Okay, a square of the binomial. If you don't feel comfortable, just multiply by itself. Use the FOIL method. Make sure to get it all right. Okay, it's going to be x squared. The square of the binomial, we square the first one, so that gives us a 9x squared. Then we multiply these 3 together. You see, 2 times 5 times 3. The sign is going to be negative. Okay, 2 times 5 is 10. 10 times 3x would be 30x. Okay, plus the square of a second one, which is 25. Okay, equal to the 5. Okay, a square of the first, 9x squared. 2 times first times second. It's going to be 2 times negative 5, 10, negative 30x. And the square of a second one. So since we get the x squared, combine the like terms, and then try to use factoring or otherwise. It's going to be 19x squared. That's going to be negative 30x. Okay, 25 equal to the 5. So move the 5 to one side. Okay, I'm sorry, that would be 10x. 9 and 1, 10x. So it's going to be 10x squared minus 30x minus 30. Okay, you subtract the 5 is going to be plus 20. Plus 20 equal to the 0. You must make it into 0 to be able, to solve it. So we get the 10, 30, and 20. You can divide it by 10. So that gives x squared minus 3x plus 2 equal to the 0. Now that's the easy equation. Use factoring to solve it. X minus 2 times x minus 1 equal to the 0. So that gives us 2 solutions. X equal to 2 is 1, and x equal to 1 is the other one. Okay, any question? So it's not going to be, complicated, but some people, when they square it, you see here, they square the 3x and the 5 only. They miss that twice after first time second, and then the thing's getting complicated. So this is the only place that you may miss. So you're not done. You have to find the x and the y for us. Okay, so go back, substitute here to get the y. So I want to finish it here. So I put the x equal to 1 in the first equation. So y would be 3 minus 5, which is a negative 2. So I get one solution, xy, which is 1 and negative 2. This is one solution. Okay, then you have another one. You put x equal to 2, x equal to the 2 into the equation number 1. So y would be, okay, 6 minus 5, which is 1. So your second solution is going to be 2 and 1. Okay, so we get two solutions. It's a line, and that's a circle centered at 0. Okay, centered at 0, and this is the line. You see, you have two intersections, and that's the intersection of these 2 points. Okay, any question? So the substitution method, we do it. Sometimes you may use addition method or elimination method, depends on the given problems. Okay, so let's check the kind of I check the part C2 so that you can see it, that the other case that I talk about it. Okay, so this is going to be, we have the x squared minus y squared equal to 1, and the other part is x cubed. Okay, x cubed minus y squared equal to the x. You see this one? So they have all powers, x squared, y squared. So for this one, you better, you can use elimination method. You can eliminate the y squared. So when you eliminate the y squared, the y would disappear, and you try to solve the resulted equation. Okay. So this is a negative y squared, multiply one of them by negative 1 to be able to simplify it. Okay, it doesn't matter which one is it. So I go with this one. Okay, I'm going to multiply the first one by a negative 1. So make it into a negative x squared plus y squared equal to the negative 1. And the second one is x cubed minus y squared equal to the x. Okay, now add them together. So when you add these two, would disappear. So what's going to be the leftover? The leftover is going to be x cubed minus x squared. Okay, minus x squared. On the other side is going to be negative 1 plus x. Okay, so it's a kind of cubic equation. You move everything to one side to solve it. So that gives you x cubed minus x squared minus x plus 1 equal to the 0. Factoring. You can group them together. Okay, so you factor out the x squared, and that gives you x minus 1. You factor out the negative sign, so that gives you x minus 1 equal to 0. So you have a common factor. X minus 1 times x squared minus 1 equal to 0. So from the first part, we get x minus 1 equal to 0. X would be 1. Okay, and the second one, x squared minus 1 equal to 0. X squared equal to the 1, so x would be positive negative 1. So we have only two solutions because the one is a repeated one. Okay, so we have x equal to positive negative 1 as the solutions. So you have to go back to the original one and get the y for each one of them. Okay, so let's start with the x equal to 1. You can use either equation. I'm going to use the first one. So I substitute, you see, I substitute for x. So that gives me 1 squared minus y squared equal to the 1. So that would be 1 minus y squared equal to the 1. So y squared is 0. So y would be 0. So we have one solution. X comma y is equal to the 1 and 0. So that give one solution. It would be the same for the next one. Okay, because if you put x equal to, okay, if you put x equal to -1, you get the same thing. So that give you -1 squared minus y squared equal to the 1. So that would be again 1 minus y squared equal to the 1. So would be y equal to 0. So we have the second solution is again is a -1 and -1 and 0. Okay, so this is going to be the way you do it. Okay, so the graph is, you know that. And the first one is going to be hyperbola, if you like. The second one is different, but you have to, these going to be your intersection points. Okay, and the first one is easy. It's a direct substitution. Okay, any question? So nonlinear system of nonlinear equation. This is where we get those powers. In the linear case, there is no power. No power of the x and the y are going to be 1 in those cases, but not this one. Okay, that's question number 6. Question number 1 and number 7 is a partial fraction decomposition. We give you 2 questions. Remember the partial fractions. What you are going to do is you are going to break a fraction into some easy one. We give you 3 cases. Okay, let's check a couple of them. So that's number 7. And that's a partial fraction decomposition, partial. Okay, partial fraction decomposition. Decomposition. Okay, the first one is the most common one, x over x squared minus 5x plus 6. That's it. You want to break it into a sum or a combination of two, okay, a combination of two fractions, if you like, or the easier fraction to get these numbers. Okay, so what we are going to do, we are going to factor the denominator first. So to see what type of factors do we have. So this is going to be x. Okay, you factor it. So that give you what? That give you x plus the product of 6 and the sum of 5. So it's going to be x minus 3. Okay, times x minus 2. That is going to be the case. Okay, so we are going to break it into 2 parts. Remember, we have, you see the factors are not repeated. They are linear factors. So for each factor, we're going to get one fraction. This is going to be x minus 3. And this is going to be x minus 2. We need to find a number on the top that match this identity. We call it the A1 and the A2, and then we are going to find it. Okay, so this is a non-repeated one. If it's going to be repeated, then you have to go on. You see, if it's going to be x minus 2 squared, so we get 1 for x minus 2 and 1 for x minus 2 squared. Now, how are we going to find this coefficient? We find the common denominator. So it's going to be equal to, the common denominator would be x minus 3 times x minus 2. And on the top, you see the first one, the missing factor is x minus, is going to be a1 times x minus 2. And the a2, and this is the missing factor, would be x minus 3. We find the common denominator, basically. Then 2 fractions, you want 2 fractions to be equal to each other. The numbers are the same. So the top must be the same. Okay, so there you are. At the top, we have a A1. Okay, a1 times x minus 2, and this is going to be a2 times x minus 3, and which is going to be equal to the x. You see, that's this identity. Now, we want to find a1 and a2. You need two equations. We talk about it. This is true for all x, but we can pick some numbers, nice number for x to simplify it. Nice number is the one that they make one of them 0. So the number is going to be the solution of the denominator. You see, this denominator would be 0 at 3, and that would be 0 at 2. So we pick these two numbers, and we find the a1 and the a2 quickly. Okay, so for example, if you pick x equal to 2 on both sides, you see this would be 0, because that gives you 2 minus 2. I write it down, to remind you. It's going to be 2 minus 2, and this is going to be 2 minus 3, and this is equal to 2. So this part is going to be 0. Okay, and this is going to be negative a2 equal to 2. So a2 would be negative 2. Okay, so we pick a number that make one of these coefficients to be 0, enable us to find the second one quickly. Any question? We need one more number. That was the 2. We picked the 3 now. So put x equal to 3. X equal to 3. We substitute. It's a1 times 3 minus 2. You see, the second one would be 0, because that would be 3 by 3. It's going to be 0. Okay, and this is going to be equal to x, which is 3. So 3 minus 2 is 1, so that gives you a1 equal to 3. Okay, so now we can have the composition. The composition of the fraction is going to be, this is x over, that's a given one, it's x squared minus 5x plus 6. Now we make it into a1, 3. It's going to be 3 over x minus 3, and the a2, which is a negative 2, minus 2 over x minus 2. So that's a partial fraction, okay, decompositions. For the purposes that we have in future, these are much easier to handle rather than the first one. Okay, any question? So this is where we get these linear factors. They are linear factors. There is no power over here, so it's not going to be repeated if you like. If there is going to be any power, you have to repeat it. That takes a little bit more time to do it. So what I do is I do one with these are linear. Suppose one of them is going to be quadratic, if you like. That takes a little bit more time to explain that one. That is part E. Okay. So that's basically two types, the quadratic and the linear. Let's see. This is it. It's a 2x squared minus x plus 2. And on the bottom is x minus 1 times x squared plus 2. That's the most general one that you may be given. Okay, one linear factor, one quadratic. This quadratic is not factorable. You see, this is x squared plus 2. So you have to take it as is. So how are we going to break it? This is it. So this is the given one. 2x squared minus x plus 2. Denominator is x minus 1 times x squared plus 2. If we break it, you see one fraction x minus 1 It is linear, the power of x is 1, so we get only a1 on the top. You see, the degree of the top must be less than the degree of the bottom. Degree of the bottom is 1, so less than means no degree, no x. Okay, degree is 0. Now the second one, we have x squared plus 2. You see now this is x squared. Degree of the top must be less than, so the less than the degree must be 1. So you're going to have something like, we call it a2x plus a3. Okay, when the degree of x is 1, you just put the a1 on the top and number. But when the degree is higher, is x squared, so you need an x. Okay, now find the common denominator. The common denominator would be what? Would be x minus 1 times x squared plus 2. So for a1, the missing factor is x squared plus 2. And for the other one, a2x plus a3, your missing factor is x minus 1. So it's going to be times x minus 1. Okay, let the top two be equal to each other. Let's start with this one. So it's going to be a1 times x squared plus 2 plus a2x plus a3 times x minus 1. And this would be equal to the 2x squared minus x plus 2. Okay. Now we talk about the options that we're going to have. So we have three unknown, you see, a1, a2, and a3. So we need three numbers to take care of it. Do we have a nice number? Only one. You see, because this is not factorable to get something nice for this one. So we start with the one that would give us one of the variables. Then we can pick two other numbers ourselves, okay, two nice numbers to be able to take care of it, okay? So this is the way we do it. So I pick the first number first, x equal to 1. That would be helpful because this is going to be a1. If you put x equal to 1, that gives 1 plus 2. Over here, since you put x equal to 1 here, 1 minus 1 would be 0. So everything would be 0. You see, on the other side, remember it's both sides. Replace x by 1, so that gives you 2 minus 1 plus 2. Any question? Now 1 and 2 would be 3. 3a1 equal to, and this is going to be 4 minus 1, which is equal to 3. So a1 would be 1. That's going to be your a1. Any question? Now we need two more numbers. Just pick something nice, you see. You can pick any number you like, but pick something that's make it easy. So the nice number is, you can pick 0. I mean, you can pick 10,000 if you like, but 0 is nice. Why? Because if you substitute the 0, let's see what we have. Over here is going to be a1 times 0 plus 2. You see, over here, make this one 0 right away. I write it down for you so that you see it. a2 times 0 plus a3, and this would be 0 minus 1. And on this side would be 0 plus 2. Okay, so that gives us a 2a1. This part would be 0. So we have the a3 is a negative 1 minus a3. Minus a3 equal to 2. Okay, but you already got the a1. a1 is equal to 1, so that a1 is equal to 1, so we substitute That gives us 2 minus a3 equal to 2. So the 2 and 2 would cancel out, so a3 would be 0. Okay, so that gives you a3 equal to the 0, the second number. Any question? So we got the a1 and a3. We have one more to go. So pick another number. You already used the 1 and the 0, so you better use something like a negative 1. Okay, if you put the negative 1 in both sides, what's going to be the result? It's going to be a1 times negative 1 squared, which is a positive 1. And this is going to be a2, again negative 1. a2 times negative 1 plus a3 times negative 1 minus 1. Remember both sides, 2 times negative 1 squared minus negative 1 and the plus 2. Okay, simplified, negative 1 squared is 1, 1 and 2 is 3, 3a1. And over here, this is going to be a negative 2. Okay, so this is going to be a negative 2. I multiply inside, so that would be another negative, so make it to the positive 2a2. And this is going to be minus 2a3 equal to what I have here. Negative 1 squared is going to be 1. That's give you 2. Positive 1 and the 2. Okay. So which is going to be equal to 5. So 3a1 plus 2a2 minus 2a3, which is equal to the 5. Okay, but we have some. We have what? We have that the a1 is equal to 1, a3 is equal to the 0. So substitute. So that gives you 3 plus 2a2, a3 is 0. Okay, minus 0 equal to 5. So that gives you 3 plus 2a2 equal to 5. So 2a2 would be 5 minus 3. So 2a2 equal to 2. So eventually a2 would be 1. So we are ready. You see, it takes a little bit of time to do it. And we just wanted to know it in case you want to do it in the future, but we give you something shorter on the test. So you are not done. You have to give us the decomposition. So this is the final answer. So the 2x squared minus x plus 2, okay, divided by x minus 1 times x squared plus 2 is going to be equal to a1. a1 is 1, so it's going to be 1 over, it's going to be 1 over x minus 1, that's a1, plus a2x, which is x, a3 is 0, so over x squared plus 2. So that gives you the decomposition of the given expressions. Okay, so in the college algebra, we just want to make sure you get the idea, but it depends what you want to do in future. So you just know a mild one, you'll be fine in college algebra. It depends if you want to do the calculus series. If you want to take calculus 1, 2, 3, so you are going to be getting involved quite a lot in this type of problems. But for mild calculus, that number 1 is okay, would be enough really. That's it. You see a short form, and usually give you this one on the test. Okay, and the rest are going with the one that we did on your quiz, I think. Let me just give you one of these log equations, like number 4. I don't remember if I did this before, because we focus on the exponential function, and we have only a single log equation. Let's give you one of them just to remind you. It's a very mild. We did all the exponential one this time. See, like for a, if you want to solve this equation, we did solve the exponential one. We give you on the test, on the quiz. So this is the first one. It's a log of x plus 6 minus log of x equal to the log of x plus 2, you see. Remember, you can solve this type of equation if you have a single log only. It's like the exponential function that we did. Okay, a single log only. So you have to change them into the single. Remember those problems that we give you on the quiz? You see this one? You know that if you have a difference, you change it to single log by using the quotient. If you have the sum, we change it to the log by using the product. So in this case, we're just using the quotient to change this one. So it's going to be the log of a quotient. X plus 6 goes on the top, x on the bottom. And this is going to be equal to the log of x plus 2. That's it. We have a single log. Remember the one-to-one property? There's no canceling in log, no canceling. The input must be the same. Okay, so that gives x plus 6 over x equal to x plus 2. You see, no log. So we change it to the single log. If it is equality of 2 log, now you can cross multiply to solve this equation. So that gives x times x plus 2 equal to the x plus 6. You solve this equation, you x squared plus 2x equal to the x plus 6. Because of the x squared, you move everything to one side. You see? And you try to solve it. X squared plus x minus 6 equal to the 0. Factor. X plus 3 times x minus 2. So we have two solutions. X equal to negative 3 and x equal to 2. But make sure that you know they are correct solutions. The correct means you cannot have the ln of a negative number. You see? You check to make sure that you are not going to provide these negative numbers. If you put x equal to negative 3, you see here, that gives a log of negative 3, which is impossible. Okay, so if this is going to be the case, then log of negative 3 is undefined. So this cannot be a solution. But if you put x equal to 2, it's fine. Because that gives you log 2. They're all positives. So when you do this type of operation, make sure to get to the good one. So this is a kind that we didn't before. Okay, I post a take-home one for you so that it helps you to practice for the test. So there are going to be the topics that's going to be on that take-home one is going to be covered on the test. Okay, 11 questions. So take care and see you. Okay. On Monday, okay, a week on Monday. Remember, no class next week, but as when we come back on Monday, we give you the test number 3. Okay, you can drop your lowest test and lowest quiz, but you better practice on this one because everything on this would be repeat it on the final. Okay, these ideas that we talk about it. So, and the final is coming, you know that very soon. So it's nice to keep this, keep up really, even if you want to drop this test, because you can. But just put them together, ready for the final, and that would be good for you. But anyway, even if you get 100, I have to drop it. Okay, have a good one, and take care. Okay, bye-bye. I will do the quiz, and tomorrow probably I will post it for you, okay? And with the solution, just check those solutions. If you miss something, make sure you're not going to miss it on the test. Okay, take care and bye-bye.